So not as lengthy of a list, but I think it is actually equally as important, if not more important, than the rational powers properties. So the title of this section is not, simplifying rational powers, but rather radical expressions. So I'm going to give you some properties of radical expressions. So there's only two. Luckily, there's not five of these. So the first one, same thing. I'm going to kind of start it off with a little bit of it. Actually, you know what? I'm going to give the general form first and then give examples. I think it'll be a little easier to understand. So in general, we saw that we could have something like this. This is just an example of a radical expression. I've got the nth root of a times b. Okay, I can actually pull this out. Since both of these two are under the same radical, I can split it up into two radicals. This is the first property. I can take the nth root of a and then multiply it out by the nth root of b. Now, this is actually going to be very, very useful for us in our assignment and for the future of us dealing with radical expressions and rational powers, okay? So this is the first property. Very big one. Very big one. The second one won't be as big, but it's still useful enough to make things a little nicer looking. So I'm going to erase this portion. I'm going to get to the second property, which, like we did earlier, we did multiplication for the first one. Or actually, you know what? I'm going to do an example of the first one first. So I'm going to write this property back down, but a little bit smaller so I get a little bit more room. I said that this is equivalent to the nth root of a times the nth root of b. So let's get some examples of numbers and letters going on in here. I'm going to do my first one as being, let's say I'm going to take the cubed root of 8 times 27. Now, normally 8 times 27 would be written down as some number, and we would have to figure it out to get 8 and 27 out, but we're going to do that later. So first thing what I'm going to do is I'm going to break this up using my property. I can say, hey, look, I've got two things inside the radicand. What I'm going to do is I'm going to break it up into a cubed root of each. So this is going to be cubed root of 8 times cubed root of 27. And what's nice, actually, is these have good answers. So the cubed root of 8 is going to be 2. The cubed root of 27 is going to be 3. This gives me 6. Okay, I'm looking for a number that multiplies 3 times by itself to get 27 and 8. That's 2 and 3. So that's the first example. I'm going to do a variable example too, and then we'll move on to the second property. So the second example I'm going to do is going to be the fifth root of, let's see here. I'm going to do a to the fifth times b to the fifth. So I'm going to do the same exact thing. Break it up into the two fifth roots. So I've got the fifth root of a to the fifth times the fifth root of b to the fifth. And what I see here is whenever I have a fifth power and a fifth root, they cancel out to just 1. So I'm left with a to the first, or we could just leave that as a if you want, and b to the first, or you can just leave that as b if you want. So my answer is just going to be a times b for that one. So basically, it's useful for us to be able to break these things up when you have two things inside of an expression or more. We'll see that you can have more than two into many different ones to piece them together individually to make a nice result. That's the first property in action. So let's move on to the second property. Like I had mentioned, we do multiplication first and then we tend to do division. If I'm taking the nth root of a fraction, something like this, you can kind of rationalize, no pun intended, with radicals, what we can do with this if we have a fraction on the inside. I'm going to piece this out and I'm going to say, okay, I can take the nth root of the top and divide it by the nth root of the bottom. This is the second property. Like I said, we won't use this one as much, but it may show up a couple times for us to work through some problems with because it might show up. So I'm going to use a numerical example first. I'm going to start off with something like the fifth root. The top I can make something like 32, and the bottom I can do 243. Okay. This doesn't look like it's going to be a really nice answer at all, but let's break it down and see if we can find some good numbers to use. So by applying my property, I can take the fifth root of the top and the fifth root of the bottom and break it up into two separate things. So I got the fifth root of 32 on top, the fifth root of 243 on the bottom. The top simplifies down to something very nice. I want a number that I multiply by itself 5 times to get 32. That just so happens to be 2. Most of the time we'll pick nice numbers for this. But you will obviously be able to use a calculator to do something like this last one. So the bottom one is going to simplify down nice too. It just so happens that the number that you multiply by itself 5 times to get 243 is 3. So we get 2/3 as the simplified answer for this one. But the big idea is breaking this entire radicand into 2 parts. One on top and one on bottom. I'm going to do another one. I'm going to keep the property up there. Let's say I've got some variables now. I've got the cubed root. Let's do a to the 4th over b to the 5th. Well, I'm going to do my property. Okay, so the top becomes the cubed root of a to the 4th. The bottom becomes the cubed root of b to the 5th. I'm going to leave it like this because we haven't really dealt with how to simplify something like this, but this is technically just using the property. When it comes to taking the cubed root of the top and putting it on the top, taking the cubed root of the bottom and putting it on the bottom. You can almost think about us taking the entire radical expression and distributing it in to the top and to the bottom. So that is how you apply the first and second properties for radical expressions.